A very good morning to our examiners and my fellow classmates. We are from Group 1 and today we are proud to present our project, the Intelligent Movie Recommendation System. My name is Haziq Hazimi and I'm joined by my groupmate is Iman, Anis, McAllister and Jesse. Our goal was to move beyond simple data retrieval and build a system that can actually reason about user preferences and using logic programming. On the second slide is about the semantic network diagram. If you can see here, this is our semantic network diagram of our movie recommendation system. I will give you the explanation about this semantic network diagram. To understand how the system works, we must first look at its brain. This diagram maps out the knowledge structure of our domain. At the center, we have the user that's shown in pink. The user is connected to various entities through the specific relationship. For the first example is the preferences. We link the user to genres and actors. And for the second example is for the history. We track what the user has watched, which connects them to the specific movies. And for the last is movie attributes. On the right side, you can see that movies are defined by their attributes. For the example, they have a genre, star, an actor, and uh, directed by a director. This network serves as the blueprint for our product knowledge base. By traversing this link, our system can infer recommendations that match the user's specific taste. For the example, from the user goes to the director and goes to movie. So that's all from me. So now Anis will explain how we initialize the system and handle user safety. Thank you.
So now I will explain how our system works. As you see in the slide, figure 2 shows a starting code of our system, which is start predicate. This part initialize the system and display a welcome message that you can see on the screen. It's also required the user to enter their name using read, which is the user. Apart from that, in figure 3, you can see the actual system interface. Here, user named Ahmad enter his name. This step important because in the system, it creates a personalized session for Ahmad. It will ensure this his data, preference, and recommendation are stored separately and not mixed with others. After the user enter the name into the system will apply a safety features which is called safety logic. So, as you can see in the slide, figure 4 shown, the system asks for their age and store it as a fact called user age. This will allow the system know the user age during the recommendation process. This is very important because movie database contain different kind of maturity rating such as 18 plus and restricted. As you can see in the figure 5, Ahmad enter his age 20. Also, the system will allow him to view all movie category. However, if your user enter such as 12 years old, so the system will automatically block any movie that rated 18 plus, even the user like the genre. This will ensure the recommendations are safe and age appropriate.
Uh, Hello, my name is Ainoriman. So I will continue with genre preference. So once the profile is saved and set up, we begin the interview phase to narrow down the search purpose. search purpose. First, we look at the genre. In this figure, you see the ask preference predicate. Instead of asking open-ended question, we guide the user through specific category like sci-fi, action, and drama. In the interface is shown Ahmad confirms he likes sci-fi but no to action. The system take yes response and dynamically asserts a fact like user like genre, Ahmad likes sci-fi. This is the first layer of our filtering process. So we move to next slide, actor preference. So now I will explain about actor preference. Uh, we know that the user often watch movie just because their favorite actor is in it. So that is star power in the code. So in that the top figure, the code where we query for specific A-list actor defined in our database. And the bottom figure, Ahmad confirmed that he likes Leonardo DiCaprio. This creates a high priority rule in our system. Later on, if a movie stars is Leonardo DiCaprio, it will just be recommended. It will be flagged with a special reason, like it features your favorite actor. This make recommendation feel much more personalized. So we move on to McAllister. He will explain logic regarding director and sequel.
Thank you very much, Mal. And hi, I'm Mike Lister, and I will be presenting on the director preferences. So here it shows beyond actors, sophisticated viewers often follow specific directors. So the figure here shows our as director preferences predicate. So here we need to check for loyalty to directors known for distinct style, such as Christopher Nolan or James Cameron. In the figure showed, the user answers yes to Christopher Nolan. This is a powerful data point in our knowledge base. Nolan is linked to movies like Interstellar, Inception, and The Dark Knight. By confirming this preference, the system opens up a pathway to recommend the specific titles. So moving on would be the watch history and sequel logic. So finally, we tackle a common problem in recommendation system, which is suggesting movies the user has already seen or watched. So the figure shown here shows our Ask Watch History code. Here we will ask the user if they have watched any specific key movies. And here the next figure shows that step 4 that Ahmad confirms he has watched Toy Story. So this serves a dual purpose. Firstly, we exclude Toy Story from the final list. Then secondly, and most importantly, this triggers our sequel logic. Since the system knows that Toy Story is part one of a franchise and the user has watched it, the system automatically infers that part two, which is Toy Story 2, is a highly relevant recommendation, even if the user didn't explicitly ask for it. Thank you. So next, Jesse will now reveal the final result and conclude our presentation.
Thanks, McAllister. Now that we have gathered ages, genres, actors, and directors, and history, we need to process it all. Process it all. Okay. As shown is above, it shows that the engine of our system, the general recommendation predicate. We use the prologue to build in the Findle. This command aggregates every movie that matches any of the user's criteria into a single list. It checks a genre rule, the actor rule, the director rule, and the sequel rule simultaneously. This ensures we don't give just one recommendation but a comprehensive list of options. And here is the final result. In these figures that shown here above, the system has successfully filtered thousands of possibilities down to three perfect matches for Ahmad. So, number one is Interstellar, recommended because of the director match, the director which is Christopher Nolan. And number two is Toy Story, is recommended specifically because of the sequel rules McAllister explained just now. Since Ahmad watches the first one, the system knows he needs to see the second. Notice that the Dana is not here, but if Ahmad was under 18 or is here if he is over 18, the reasoning is transparent and explained to the user. Right, to wrap it up, uh, as you can see, the figure one shows that it shows our cleanup process. We use Retracker to wipe the temporary facts about Ahmad, his age, his likes, his history. This reset the system so the next user start with a clean state. As for the figure below it, it shows the exit screen. This project demonstrates that Prolog not just a database, it is a logic engine capable of complex, personalized reasoning. Alright, that concludes Group 1 presentations. Thank you for your time.